All right, so when we're talking about the total amount of time spent on Wednesday through Friday, they gave us extra information that we don't necessarily need. We just have to focus on Wednesday through Friday, and the total time means that we're going to be adding it together. So we're going to take Wednesday, Thursday, and Friday and add that value together. So 3.15 plus 3/4 plus 4 1/2. When we add all of that together, it's going to come out to 8.4. Now, if the answer choice happens to be a mixed number, then you would just have to convert it to fraction, then mixed number, which would have come out to 8 2/5. 8 2/5, which makes sense because the whole number in the decimal is 8, which means the whole number for your mixed number is also going to be 8. And it's just 0.4 that you have to focus on converting into a fraction, okay? All right. Number 2. Number 2 goes to seat number 11. Who's at seat number 11? All right, what did you get for problem 2? Five and 33/40 is correct. Very good. Chocolate or not chocolate? Chocolate? Okay, ready? Hopefully I don't hit you. Here we go, ready? Woohoo! All right, so we are talking about the difference. Remember, the word difference means that you are going to be subtracting these values. Difference means you are going to subtract. So we're going to take the height of Jessie, which is 68 1/5, and we're going to subtract the height of Jillian, which is 62 3/8. Again, you get to use that calculator. When you do the subtraction, it's going to give you an improper fraction. You need to make sure that you convert it into a mixed number. 5 and 33/40 would be the correct answer. Okay? Got to make sure that you know how to use your calculator correctly. All right. Problem number 3 is going to go to seat 31. Seat 31. What did you get for problem number 3?
I didn't do that one yet.
Okay, let's move on then. Seat 6. Who's at seat 6? 8 is correct. Would you like chocolate or non-chocolate? Chocolate? All right. Can you have peanuts? Are you allowed to have peanuts in it or no? Yes? Okay. Very good. All right, so 8 days is correct. Brittany's got a gift card. She's got a gift card to Starbucks. Woohoo! Has $33.92 still on the gift card, and she is going to order her, daily addiction of coffee. That's $4.24 per order. So if she orders it each day, we want to know how many days is she going to be able to buy that coffee before it runs out. So we know that every day it's going to cost us this much. So we're splitting it into equal increments. By splitting it into equal increments, that is division. You are going to be dividing. That's important. Leslie, cover the face, honey. Okay, so we're going to take $33.92 and we're going to divide it by the $4.24. Right? That's the total amount that she has on her card. This is the cost per day. Cost per coffee. So we're going to divide the total by the cost per day to figure out how many days it's going to last. And it's going to last 8 days. Okay? Problem number 4. Problem number 4 is going to go to seat number 1. Seat number 1. What did you get, Tiv? Sorry. Huh? Problem number 4. What did you get for problem 4?
19 over 24.
19 over 24 is correct. Do you want chocolate or non-chocolate?
Chocolate.
Chocolate. Okay. Yep, ready? Okay, let's finish this up and then we'll go to lunch, okay? Hector and Jamie purchased tickets for a fundraiser. Hector bought 2/3 of the tickets and Jamie bought 1/8 of the tickets. How much of the fundraiser tickets did they buy all together? All together means that you're going to be adding. All together means you are going to add. So we're going to take Hector's 2/3 and add it with Jamie's 1/8. And that's going to come out to 19 over 24. Okay, and then the last question goes to seat number... Oh, well, she already answered before. Oh, so did that person. Why is it generating the same people? Okay, seat 29. Seat 29. Who's that?
Me.
Okay, Noah, what did you get for problem 5?
1 and 1/2.
It's not 1 1/2. Let's try somebody else. Seat 33. Seat 33. Yeah, what did you get? 5 over 8 is correct. You want chocolate or non-chocolate? Did you want chocolate or non-chocolate? Not chocolate? Like nerds? Okay. Okay, here you go. Ready? Catch. All right. So for here, now this is a really important problem. I want you guys to go ahead and put a big star by it. The star by problem number 5. A cookie recipe calls for 2.5 cups of sugar. You plan to make only 1/4 of the recipe. 1/4 of the recipe. So here's the thing. We're saying that we're going to make 1/4 of the recipe. Do we know how much the recipe is? The recipe is what? 2.5, right? The recipe is 2.5 cups of sugar. So we can change this to 2.5. So we're really saying 1/4 of 2.5. And who remembers what operation is the word of, Lexus? Multiplication. Of means to multiply. Of means to multiply. So we're taking 1/4 times 2.5, and that's going to come out to 5 over 8. Guys, were these problems really hard? Not really. And guess what? The first 5 questions on your test are exactly like this. If you can do these 5 questions, then the first 5 questions on your test you can do, because they are exactly the same, but different numbers. Let's line up. All right. We're moving out of word problems right now. We're getting into talking about putting rational numbers on a number plot or on a number line and how to compare your rational numbers. You will have a few questions on your test in which are involving you doing so. So in order to make an accurate comparison, when you are comparing rational numbers, in my opinion, the easiest way to make a comparison is to convert that number into a decimal. I think that you guys have an easier time comparing decimals than you do fractions. So that's my suggestion to you, is to convert it into a decimal prior to you trying to make a comparison or prior to you placing it on a number line. So taking a look here at problem number 1, 7 over 10. 7 over 10, remember to do your conversion, in your calculator, you're going to hit your fraction button. You would type 7 over 10, get out of the fraction, and remember, you can convert quickly by just hitting this white button at the bottom, that double arrow button, and then enter, and you'll get 0.7, 0.7. So I recommend that you go ahead and do your conversion that way. convert, we get 0.7. And now somebody go ahead and do 3 over 5. Raise your hand to tell me what is 3 over 5 as a decimal. What is 3 over 5 as a decimal? Glory?
3.5.
No. Now, it's 3.5. That's a common mistake that people make. 3 would have to be a whole number. If it's 3.5, then that would be 3 and 1/2. That means you would have a mixed number. We don't have a mixed number here. Okay, we have a fraction. It's less than 1. Okay, use your calculator next time, please. Angel. 0.6. 0.6. Please make sure you use those calculators to do your conversion. Don't just guess. Okay? So now we're comparing 0.7 to 0.6. Is 0.7 greater than, less than, or equal to? Greater than. So we're going to put the gator mouth opened up to the larger number. You guys remember that? This is greater. 0.7 is greater than 0.6. That means 7/10 is greater than 3/5. So there's our answer. Okay? Yes, Lexus. Okay, one more time. To convert into a decimal, you're going to zoom in. You're going to type in your fraction. So let's say that we've got a fraction of 6 over, I don't know, we'll say 6 over 15. And I want to convert this into a decimal. So I'm going to type in my fraction. Here's my fraction button. Then down here at the bottom, above the enter sign, is that double arrow white sign. You're going to press that double arrow. Press it once. So you should see the double arrows. You see them? So 6 over 15, once you press the double arrows, you should see that, and you hit enter, and it gives me my decimal, 0.4. I can hit it again, hit the double arrows and enter again, and that's going to give me 2/5. So that's the fraction in simplest form. Okay? All right. So let's take a look at problem number 2. Problem number 2, we've got negative 1/3. Negative 1/3. Who can raise their hand and tell me what is negative 1/3 as a decimal? What did you get, Amaya? Don't forget the negative. Negative 0. And it's not just 0.3, it's 0.333. It keeps going on, right? It's repeated. It's repeated. Okay? Then I've got a negative 3/4. A negative 3/4. Joshua? Negative 0.75. Good. So now what we're doing is we're comparing. See how negative 0.75 only has 2 numbers behind the decimal? I'm going to go ahead and make sure that I've got negative 0.3 repeated as just 3 numbers behind, or 2 numbers behind the decimal as well, so that they have the same number. Now these are negatives, so keep in mind, the larger the number, the smaller the negative is. So 0.75 is bigger than 0.33, so that means negative 0.33 is actually going to be bigger than negative 0.75. So we get greater than again. Okay, let's look at number 3. Number 3, we got 1 and 1/2 compared to 1.456. 1 and 1/2 compared to 1.456. What is 1 and 1/2 as a decimal, Emily? 1.5. We have 1.5. And now we're comparing that to 1.456. So, common mistake. A lot of people immediately think that this one is the bigger one, that 1.456 is bigger. Why do you think that they think that's the bigger one, Lexus? Yeah, it looks bigger because hey, if I look at it, it's 0.456. This is only 0.5, and 456 is bigger than 5. That's not the same comparison. When I notice, hey, I've got 3 numbers behind that decimal, right? I got 1, 2, 3 numbers behind the decimal. Well, I'm going to go ahead and put 3 numbers behind this decimal. I'm going to put 1. Well, what can I add behind it, Caden? Zeros. I can add as many zeros as I want behind it, and it doesn't change the number. So now, instead of me saying, oh, I'm comparing 456 to 5, now I'm comparing 0.456 to 0.500. Which one is going to be bigger? The 0.500, right? So 1.5 is greater than, it's greater than 1.456. Okay, now placing these on the number line. Placing these on the number line. The best thing you can do, once again, is convert each one of these first into a decimal. So real quickly, I'm going to go ahead and convert this. -6/10 is the same thing as -0.6. -0.6. 1.8 is 1.8. -0.2 is -0.2. 5 over 3 is the same thing as 1.6 repeated. That's 6, 6, 6, 6, 6, 6 keeps going on, okay? -1 3/9 is the same thing as -1.3 repeated. So -1.333333333 on and on forever. So now we can go ahead and place these where we think that they would belong. So let's look at point A. Point A is a negative. Is that going to be to the left of 0 or to the right of 0? To the left. Negatives are going to be to the left side. There's our negatives. Positives are going to be to the right side. There's all our positives. Okay? So we're focusing on a negative. In fact, I'm going to go ahead and write this as -0.6 in pink. So I know it's my negative. So now it's -0.6. So let's focus on the 0.6. What 2 numbers is that going to fall between? Emily? -1 and 0. It's going to fall in between the 0 and -1. It's going to fall in between 0 and -1 because the whole number is a 0. The whole number is a 0, right? So it has to fall in between these 2 numbers. And it's roughly a little bit more than halfway. So I'm going to go ahead and put A right around here. It's just a rough estimate. There's my A. All right, B. Let's do B in green. Let's do B in green. 1.8. That's a positive. Between what 2 numbers is 1.8 going to fall? Leslie? 1 and 2. Is it going to be closer to the 1 or closer to the 2? Closer to the 2. Right? So it's not halfway, because halfway would be 1.5. So it's going to be a little more than halfway. It's going to be maybe roughly around right here. Again, it's just a little estimate. It's not anything exact. There's B. All right, let's do C in blue. Let's do C in blue. -0.2. So that's also going to fall between the 0 and the -1, isn't it? But now, let's look a little closer, though. We've got a point already plotted there, -0.6. Is it going to be to the left of it? Is it going to be between -1 and A? Or is it going to be between 0 and A? Between 0 and A, right? Because -0.2 is closer to 0 than point A is. So we're going to plot that right around here. There's point C. All right, we've got positive 1.6, a positive 1.6. Again, that 1.6, that's going to fall between 1 and 2, isn't it? But we've already got a point there. We've got point B. So is it going to go before B or after B? Before. We'll go ahead and do that in orange. It's going to go before B. Just a little bit before B, isn't it? Almost right on top of B. There's D. And then the last one, we've got negative 1.3 repeated. Negative 1.3 repeated. We'll do that one in purple. Between what two numbers is that going to fall? Negative 1.3. Jael, what do you think? What two numbers is it going to go between? Did you change your mind? You don't want to answer? What do you think, Rueda? What do you think? Between what two numbers is negative 1.3 going to fall? Between which two numbers up here? Negative 2 and negative 1, right? Negative 2 and negative 1, that's where it's going to fall between, right? We know it's got a whole number of negative 1, but it's got a little bit more than that, so it's going to keep going past it. So it's going to fall in between here somewhere, not quite at the center, just a little before the center of it, and there's point E. All right, now that we've got them plotted here, these points are now in order from least to greatest, aren't they? There's our smallest point is E, followed by A. C is our center point, D, and then B is our largest number. So now we can make our comparison. Let's compare point A and point D. Point A and point D. A is what?
Negative.
Is a negative, yeah. But compared to D, is A greater than, less than, or equal to D? Less. A is less than D. So we can actually put that down. I'm going to write A. I'm going to put a less than sign. And then I've got D. I'm going to use those colors so that I know where it refers back to on the grid. What about B and E? B and E. So we're comparing B first to E. Is B less than, greater than, or equal to? B. B is greater than. B is greater than. So I'm going to put a greater than sign. B is greater than E. B is greater than E. Okay, I want you guys to try this grouping on your own. Don't forget, what do you have to do first with absolute value? You have to take the absolute value first, right? What's the absolute value? 4.45? 4.45. Let's go ahead and again continue with A being in pink. B is going to be in green. C is going to be in blue. D is in orange. E is in our purple. Go ahead and try this one on your own. Place them on the number line and then compare A and D, B and E. Make a comparison for A to D. Make a comparison for B to E. All right, let's go ahead and go over this. Each of the tally marks, so remember between 0 and negative 1, there's 10 tally marks it takes us to get there. That means each of these marks represents 1/10. So let's start with C. C is between negative 1 and negative 2. That means it has a whole value its whole value is going to be a negative 1, and then we have to count the tally marks. What's the tally fraction mark represent? How many mark over is it? 9, right? This marking right here, that's a negative 9 over 10. So that's negative 1 and 9 tenths. Negative 1, because we passed to the negative 1, so we know we got a negative 1 there. And then we went 9 marks over, so that's 9 over 10. So negative 1 and 9 tenths for problem C. For problem F, okay, it's between the 0 and the negative 1, so is there a whole number? No, right? It's not past the negative 1, so it's not going to be there. How many tally marks over is it, though? What's that fraction represent? 9, right? Negative 9 tenths. So this is negative 9 tenths. Negative 9 tenths for F. B is just 1 mark ahead of it. So what is that 1 mark ahead of it? Negative 8 tenths, right? Negative 8 tenths. But we can simplify negative 8 over 10 to negative 4/5. So B is negative 4/5. E is only 1 mark to the left. So that's a 1/10, right? A negative 1/10. D is now to the right of 0, but it's not before 1, so it's still just a fraction. Still just a fraction. And let's count it. It's 1, 2, 3, 4, 5, 6 out of 10. It can be simplified, though, to 3/5. 6 out of 10 can be simplified to 3/5. And then A, we're going to do that one in green as well. It's past the 1, so we know it has 1 whole. And then it's 1, 2, 3 tenths over. So 1 and 3 tenths. Okay? Don't worry about the rest of this sheet. What I do want you to do, though, is tonight for homework, you're going to do pages 19 and 20. Pages 19 and 20 for homework. We're going to go over it in class tomorrow.